Alright, in this video we're just gonna go over some of the guided practice problems, which are basically 4 through 9. I'm not gonna do 4 and 5 because, like I said, I think you guys can figure that one out. And 6 is saying determine whether the following statement is always, sometimes, or never true. Explain. The intersection of three planes is two lines. It can sometimes be that. So for that one, I'll just put sometimes. Let's make this smaller. Yeah, that's fine. Sometimes. Now the reason I say sometimes, because it's not always the case. Because usually three planes can actually intersect at three lines. And as a matter of fact, if you guys remember, in the very first assignment we did, one of the answers for the drawings, I think it was number 28, just showed three planes and they was intersecting at three different lines. It kind of looked like this. This is one plane here, there's another plane here, and then the other plane was here. So they intersected here, here, and here. Obviously this drawing is horrible, but just to give you an idea. And again, it actually will look better. Alright, the other part that you have to do for your assignment is really simple, which is this here in the figure, which is this, obviously. Line BD and ray BR are in plane P. So line BD, which is this line really, and BR is this. Even though they said BD since it's a line, they're implying that W is part of that line. And this is BR. This is coplanar. The actual name of this plane could be plane P, or let's just review, it could also be DBR or RBW, as long as there's 3 points in the plane that are non-collinear. Can't use E because that's not in the plane itself. And moving along, with W is on BD, correct, which is what they just is basically what I just talked about. State the postulate or definition that can be used to show each statement is true. So all those postulates you copy for notes, all you got to do is just pretty much match them. So for this one, B, D, and W are collinear. That is true because based on postulate 2.5, it says if 2 points lie in a plane, then the entire line containing those points lies in that plane. So these 2 points are in the plane, they make a line. Any points within that line, in this case is W, is also within the plane itself. So for this one, the postulate for this one would simply be 2.5. As long as you're copying the question, you just put 2.5, then I'll be able to get it and you'll be able to get it too. Because if it's in your notes, then you know what you're talking about. So will I know what you're talking about. Alright, number 8, E, B, and R are coplanar. E, B, and R are coplanar. That is technically true. In this case, they're not. Not for plane P, but by themselves, they're part of another plane because they're not collinear. So yes. And by definition, which postulate is that? Let's see. A plane contains at least 3 points not on the same line, 2.4. Or 2.2 says through any 3 points not on the same line, there's exactly one plane. That's the one for that one. Because it's basically saying if you got 3 points on the same line, there's a plane there, which is what number 8 is stating. Again, don't forget, E is not part of this plane, but E, B, R on their own can make a separate plane, which has nothing to do with P. Alright, last question. R and W are collinear. Technically they're not, but per the postulate they are. Through any 2 points is exactly one line. So that's also part of the definition. Again, don't get confused. R and W in this case aren't collinear, but on their own, yes they are, because any 2 points make a line. So yes, so per the postulate 2.1, through any 2 points is exactly one line. Correct. Just like if you wanted to say R and E, those can also be collinear. And also if you wanted to say E, R, W, those 3 points can also be coplanar, because through any 3 points, they're not on the same line, there's exactly one plane based on postulate 2.2. Alright, thank you guys. See you in the next video.